accepted. Login accepted.
I guess that's my cue. Hi everyone. Welcome to the, I guess, first post-keynote talk on the first day. So this is pretty cool. My name is Tiffany Jernigan, and I am a developer advocate at VMware. If you have no idea what that means, you can ask me about it later, but it involves doing things like this. For whoever still uses Twitter, I have my Twitter on there, and since there's too many types of social media things now, I just made like a link tree that has everything else. It just got kind of old being like, here's my Mastodon, here's my Blue Sky, and LinkedIn, and just there's too much. Anyway, this talk is about getting started with Kubernetes. Hopefully that's what you came in here for, if not, wrong room. Thanks everyone. And I guess I still see a bunch of people slowly trickling in, but I'm just gonna get started anyway, and since some of the stuff in the beginning may be familiar to some of you all. Okay, so I assume it's gonna be everyone here, but who has heard of Docker? All right, most everyone, or you just don't feel like raising your hand, that's fine. So just a little bit of like background history pretty much. So in 2013, which is basically 10 years ago now, which is kind of crazy when you think about it. But basically, Docker came along and just basically changed the container space. They didn't create containers, but they made it to be where, like, what you know about nowadays. So basically, people would be taking like their giant monolithic applications and then breaking those down into smaller components and then running them within containers. So like once you've basically broken down your application into these various components, whether it's like a ton of microservices, or if you just feel like putting in whatever monolith that you already have, or your front end, or database, whatever, each of these individual components ends up running in its own container. And then with this ability to be able to package up everything that you're running, you could be able to easily distribute it, you can easily scale up, scale down based on whatever your requirements were. So as containers started becoming more and more popular, people started to deploy those like at scale. So we had more machines, we had more containers running on those machines as well. So it basically got to a point where trying to manually manage all of these containers, everything that was being run was just kind of chaotic. Like maybe you could deal with making some sort of script or try building your own thing, and it kind of becomes a lot, especially if every single person has to go and do something like that. So basically you needed some sort of service to manage like the instances, or basically the nodes that you had, and then something to deal with managing all the containers or whatever else. So that is basically where Kubernetes came in. So it helped users be able to focus on their applications instead of worrying about like building cluster management software themselves and just like not worrying about all this extra stuff. Who here, I guess, I'm going to assume most hands or have heard of Kubernetes before walking into this room? Okay. Who has used Kubernetes before? Okay, cool. It seems like people have mostly come to the right talk for getting started. If not, hopefully you still learned something. So at its core, Kubernetes is an open source container management platform. It's basically built to help you run your containers at scale, and it comes equipped with things to help you build proper distributed applications using the 12-factor. Hello, microphone. Hi, everyone. The 12-factor app pattern. So this is also kind of old at this point. It feels like a lot of things that I'm looking at, but they're still true. So this was a quote from 2017, back in the day, which is crazy, which Kelsey High, that basically Kubernetes is a platform for building platforms. So Kubernetes can be run anywhere. You can run it on-prem. I can run it on my machine, whether I'm using Mac, whether I'm using Linux, whether I'm using Windows. It doesn't matter, which is super cool. And you can maybe you could have it in some sort of server in some office. Like you can just be like, hey, I'm going to use Kubernetes wherever you are. That probably will work. So I'm going to start getting into some Kubernetes concepts now instead of just all the background history stuff. So first, I'm going to go into cluster components. So the base point of when you're using your Kubernetes is basically your cluster. So this is where all of your nodes reside. So these can be virtual, they can be physical, they can be virtual and physical machines. And they basically come into two separate types. So there's ones for your control plane, and then there's ones for your workers. So this is kind of like a little high-level architectural diagram of a Kubernetes cluster. So your cluster is split up into two things. You have your control plane and you have your workers. And each of these can consist of multiple nodes. Having more is good for high availability because, hey, I only have one running with my workloads, and something happened to this machine, and then all of a sudden, hey, all my applications aren't working, your customers are angry, just not a good idea. So I'm going to now go into each of these components. All right, so first I'm going to talk about the control plane. So the Kubernetes control plane is responsible for maintaining the desired state of your cloud. It manages the worker nodes and the pods, which I'll explain what pods are in a bit if you don't already know, in your cluster. There is the API server. You can kind of see that it connects to everything else that is within the cluster, and it is the front end of the Kubernetes control plane. There is the scheduler, which is over there, I guess depending on which screen you're looking at, and that watches newly created pods and ones that don't already have a node assigned to them, and then selects a node for them to run on. Then there is the controller manager. At a very high level, it runs controllers. So some controllers there's a node controller, there's a replication controller, and it'll make a little more sense a little bit later. There is an optional one, which is the Cloud Controller Manager. It's used for cloud providers. Then there is also etcd, because you need to store data somehow. And it's a highly available key value store, and basically it stores your cluster data. So now let's get to the worker nodes. So the worker nodes, or node, or whatever you decide to do with that, it is where your pods, which again, just for now, if you don't know what a pod is, just think about it with your container workloads. So basically, that is where your pods or container workloads are running. So there's kubelet, and kubelet is the agent that makes sure that the containers in a pod are running and are healthy. Then there is kubeproxy, which basically enables you to talk to other services in the cluster. And it basically maintains network rules, which allow network communications to your pods from network sessions both in and outside of the cluster. Then we have the container runtime. And this is kind of where we go back to hearing about Docker, because Docker is one of the most popular container runtimes. And basically, it's there and responsible for running your containers. And so, yeah, this worker node or the worker nodes basically is, again, where all of your applications basically run. So next up, we have objects. So Kubernetes objects are basically persistent entities in the Kubernetes system, and these are used to represent the state of your cluster. So now I'm finally getting into pods. Maybe I should have mentioned a little earlier, but just the order of things sometimes is a little hard to figure out. So basically, pods are the smallest and simplest unit in the Kubernetes object model that you can create or deploy containers, basically. So they can be used to run a single container if that's what you want. You can use it to run multiple containers that need to work together. I wouldn't suggest doing something like, here is my database, and here's my Nginx, and here's my all these things inside of a single pod. It's more if you have depending on how far down the road you are, whether you put in some sort of proxy to deal with networking, and here's my application, for instance. One way you can kind of think about it is with Docker, it's a whale. And a group of whales is considered a pod, so you can kind of think that with containers. So also, if for some reason this pod stops, whether it finishes because it's supposed to or something went wrong, it won't end up restarting. So that's where we have other things such as a deployment. So a deployment, basically, you can be like, hey, it uses a replica set and being like, hey, I want to have 4 copies or whatever number of replicas of my application, which is good for high availability. And the deployment will ensure that you have that many running. If one of your pods goes down, it'll go and just create another one as a result. And it always makes sure that that many is up. And it's just another thing that you don't specifically have to worry about yourself. Then we also have things like stateful sets. And these basically manage pods that are based on an identical container spec, kind of like a deployment. But basically, they're a little different. Unlike an actual deployment, it maintains like some sort of sticky identity for each of the pods. So basically, in other words, like though they're all created from the same spec, just like what you would do with a deployment, they're not actually interchangeable. And say, for instance, you're like, hey, I want to run whatever this application is on every single one of my nodes. In that case, you would want to use a daemon set. There are also things like jobs. And those basically will run your pod or your pods until completion. And then there are cron jobs where you can be like, hey, I want this to run every hour, every 15 minutes, every 5 days, or whatever amount of time that you want it to keep running for. And you can just basically schedule it for like a specific amount of time or a number of iterations or whatnot. All right, so next up we have services. So services are used to access your application basically outside of the pod itself. So say you have some sort of pod running. I have my really cool website. It's running on my cluster. But if no one outside of your cluster has the ability to access it, that's only cool for you. Like no one else can see it. So basically, services are here to give us a stable endpoint to connect to like a pod or a group of pods. So there's a few different types. So there is cluster IP, there's node port, there's load balancer, there's external name, and I'm going to go into some of the, like 3 of them next. So cluster IP is basically the default service type. Since the IP address that you're allocated with there is actually private, you're only able to reach that within the cluster. So say someone has access to your cluster, maybe you're doing testing, whatever it is, and they have access to that, then they can go and see it. But say I have my own cluster, none of you all, unless you're specifically logged into my machine, for instance, or on my cluster in some way, are able to see that. Then we have node port. So unlike cluster IP, this can actually be reached outside of the cluster. And basically, you can use the external IP of any of the nodes and the given port that you have. And you may have to change some sort of security settings in order to be able to access it outside of your cluster. For instance, if you are using some sort of cloud provider and they have certain things locked down, you may have to fiddle with that. And then we have load balancer. So it basically, for load balancer, it creates an external load balancer for the service. So typically, this is some sort of cloud load balancer. So maybe you're using like ELB on AWS, or you're using GLB on GC, et cetera. Like, it all kind of depends. And the thing, though, with this one is, like a lot of things, if you are creating this load balancer, it ends up costing some sort of extra money. All right, so networking. So at a super high level, basically, or just like in short, everything on Kubernetes is just like one big giant flat network. There is one big subnet, and literally everything that you have is in it. You have your nodes, your pods, literally everything. So like one way to kind of think about it is, say you have like a big castle, and you have all these tall walls, and you have this moat that is around it. So if you're inside of this castle, everyone can talk to each other, everything can communicate, and in this case, it's basically like your pods and your nodes. But if you're outside, you can only get through in some specific ways, whether that's like a drawbridge or something like that. And in that case, it would be basically like the idea of having like node port or load balancer services a way for getting in. So basically in kind of a little more detail, the nodes must be able to talk to each other directly, the pods must be able to ping the other pods too, and the nodes and pods must be able to talk to each other as well. So then there is the Container Network Interface, or CNI, and if you've dealt much with Kubernetes, or actually anything in the tech space, you're probably used to the fact that so many things have acronyms at this point. So sometimes it's like, what is that? There's CNI, there's CSI, there's like, it just keeps going. But this is one of them. So basically, CNI defines like a way for kubelet to interact with network plugins. And like CNI plugins, they're just basically binary programs that can take care of like IP allocation and like setting up the network within containers. So I'm going to go a little bit into security, not so much in this talk. Some of the things that you can do are just like, for instance, there's this concept of namespaces that you can use to separate out different things that you're running within your cluster. So when you are just using Kubernetes for like the first time, for instance, or just you're using this default namespace, you could then create, say, a namespace for production or whatever you for Bob, like whatever you specifically want to do. And you could give a certain person specific access to do whatever they want in that namespace, but they can't touch another namespace. And you can do things like that with service accounts and role-based access control, another acronym. So like role-based access control, you can basically, for instance, be like, all right, so here is this like user or this group or whatever it is, and be like, hey, you can have the ability to view everything that is running in this cluster, or you have the ability to create pods or create resources, or you can delete things. Like you can just like have it more fine-grained and decide like what someone can be able to do, which is super helpful because you don't want just any person who has access to this cluster to be able to accidentally delete everything that you have running. That could be pretty bad. So yeah. There's also secrets. It's a good idea to not just like write out passwords and have them be super visible to everyone and accidentally maybe upload that to GitHub or something like that, because that happens. So there's a bunch of links on the Kubernetes docs. I have a talk that is like basically getting started with cloud native security for people who aren't already like security experts. So there is a video from Devoxx France from, I guess, like a month ago. And there's currently 2 parts of a blog. I still haven't finished the one on supply chain security because I'm bad. But there's 2 QR codes there that get both to the video and the blog if you are interested in learning a bit more about security. All right, so I'm going to drink water real quick because I'm starting to sound a little bit like a frog. Okay, so when at least initially interacting with a Kubernetes cluster, chances are you are probably going to end up using kubectl to interact with the Kubernetes API. There is also a kube config file that basically contains like all the information that you need to be able to securely access your cluster. And next up, I am going to actually show stuff via demo. Okay. So, and like a lot of the time, like when you're first interacting with Kubernetes, or even now when you're looking into things, a lot of the time you're using kubectl, but like later down the road, if you're trying to like run applications in production, et cetera, it's better to use something like some sort of CI/CD pipeline. There's less chance for human error, but like when you're still trying to figure out stuff, when you're trying to look into things, figure out what's going on, you are probably using kubectl. Since I am super lazy, I aliased kubectl to just the letter K so that I don't have to type it out. But yeah, so as I was kind of mentioning a little bit earlier, you can run it basically anywhere. So there's this cool tool called kubectx. There's this concept of contexts that you can be able to switch. If they're all inside of the same kubeconfig file, which I'll show you what that kind of looks like in a sec, you can be able to switch between different ones. So for instance, if I'm running it just like on my machine, there is like Docker desktop, there's kube8, you can deal with some stuff with kube8am. There's just a bunch of, there's just a bunch of different things that you can run where it's like, I'm running this specifically on my machine. If you end up, for instance, pulling down, running some sort of container image, and it's not like latest where it tries pulling it again, then even if you don't have internet for a bit, it's not a big deal because you already pulled it down and you can run stuff. And then I also have it running with GKE for Google. So if we just kind of look here, if we do config, oh, that's weird. All right. Sorry, what? I'm just going to unplug it and plug back in. It's like my AirTag that I bought and was like, oh no, it doesn't. Oh, wait, this still isn't. Well, this is interesting. Okay. If you've never given a talk before, this can happen. We're just going to mirror it for now. All right. Do I need to make the font bigger? Okay. All right. So what I was originally saying and talking about that you couldn't see anyway, yeah, so there's this thing, kubectx. It's an external tool. You can actually look at some of the config things specifically using kubectl, but it's a little harder to switch between things. So yeah, for what I did here is kubectl or K, because again, lazy, config view. So this basically shows what is inside of that kube config file, but it redacts some stuff, so I'm not accidentally sharing all the things with you all, hopefully. I mean, if it is and it's recorded, well, I guess I'm deleting these clusters or something. But yeah, so you can basically see the different clusters that I have within this kube config. So for instance, I have the one with Docker Desktop, which is one, like if you haven't already used it, one of the ways that you can both in general just run your containers on whether you're using Mac, whether you're using Windows, and Linux too, though you can just run it directly on Linux. It also has the ability to be able to run Kubernetes clusters. And then you can see all the other ones I have with my other GKE clusters. And then I honestly don't even remember what my Tiffany cluster is or where that's running, but I guess I'll look that up later. Not that it really matters too much, but maybe it's using up money, so that's not great either. So yeah. So basically, if I did like a get no or nodes, because depending on some of the things let you be lazy, which is kind of nice, especially if you decide later on that you want to take any of the Kubernetes certifications, being able to just like type things quickly is very important because it's timed. Yeah, so here we can, so with GKE, if you can't, like, so I showed earlier how there is the control plane and the workers. For a lot of these managed Kubernetes services, they handle all that stuff with the control plane for you so that you don't have to worry about it, which can be super nice. If there isn't something that you specifically, like, I need to be able to, like, log into the VM in my control plane, then go this way. Otherwise, you have to deal with paying people to manage it, and it's just can be a lot. So from here, I can basically just see the nodes that I have as my worker nodes. I can't actually see anything with the control plane. It basically abstracts all that way. Google deals with it, and I don't have to. So yeah, so we can see that I have 3 of them. If we do k get all, which isn't actually all, it doesn't show literally everything in your cluster, but it shows a lot of the like kind of important things, and I guess apparently I need to delete things before I do stuff sometimes. But yeah, so like for instance right now I have a deployment that's just called deployment demo 2. Super original, I know. It was from some other demo I had done. And you can see that it shows like how many are ready. It says like 2 out of 2. You can see up above that with that there are 2 pods that I created. There are services, so by default there is always the Kubernetes service. Anything else is something that you specifically run. And then, so this specifically with the kget_all is like the main stuff. It doesn't show things like config maps and some of the other resources that you have, but it's specifically for my current namespace. So if I do a kget_ns, I can see like all the different namespaces that I currently have inside of this cluster. Also, like the kubectx command, there is this thing called kubeNS, which is also made by Amit Albakan, which basically you can, if I do kubeNS, I can see and actually switch between the different ones, because it's a little faster than like trying to be able to do like k-n and then put the namespace, and then I want to do a specific thing. If you're only trying to do like one thing with that cluster, with that namespace, it's not a big deal doing a -n and then like running some application. But say you want to do everything inside of this new namespace that you created, using kubeNS will actually let you just do everything with that and not have to add a bunch more text. So for instance, I could do a k-create namespace, and since we're at Devoxx, can go and do that. If I run kubeNS again, we can see that Devoxx is there. I can do kubeNS now and type Devoxx. So if we look here, we can see that now I'm inside of the Devoxx namespace. But yeah, like again, by like default, okay, so the default namespace is the one that you end up starting in. These cube dash things are there created already for you. A bunch of like, if we wanted to look at like things in cube system, we can do that. If we do -n cube system get all, for instance. So the one downside of running on GKE during a demo or something like that is internet. But yeah, so it looks a little hard to see, but you can see a bunch of the things that like Google, for instance, has decided to run like on your cluster for you. So there's things like with FluentBit, there's GKE metrics. And then I mentioned earlier there's kubeproxy. So you have all those things that are basically running on there for you. So basically, if you wanted to, so that's kind of just being like, here, let me look and see what's on this cluster. And that is because this is my cluster. Later, you could do things with RBAC and be like, hey, I don't want this person to be able to see certain things, and not let them maybe be able to see what is running in a certain namespace. So what we could do so now you can see with the way I have my terminal set up that I have it actually telling me what cluster I am on and what namespace that I have there. So if I wanted to just run like nginx, for instance, you can do krun nginx, give it the image. So it's kind of like if you haven't already played with Kubernetes, it's kind of like if you are dealing with Docker in a way. A lot of the commands are pretty similar, at least for some of the more basic things. So you can see that it says that it created a pod. So if I get kget_po or pods, we can see that now I have nginx running. So what I mentioned earlier is that if something happens to your pod, it does not come back. So if I decided, hey, I'm just going to delete this pod, and then I get pods, and you can also do -w for watching, like nothing is going to happen, it's never going to come back. If this is some super important like application that you're having running, don't do it this way, because as soon as something crashes, which hopefully it doesn't, but it happens and you need to debug it or whatever, it's gone. Like, I can't get that back. So one of the things that you can do about that is to create a deployment. So it's basically very similar. You do k-create deploy or deployment. Again, I'm lazy and I don't like typing all the characters. Also, I apparently started only using these two fingers on this hand when I type, unlike you're supposed to use both, and now I make all these typos, so I guess I have to relearn and go back to like kindergarten level or something, I don't know. But yeah, so for instance, what I was mentioning earlier, if you are running it like on, say, Kind, or running it on like Docker Desktop, for instance, and maybe you're working on a demo, like I was doing beforehand at some point, and you don't have internet. If you give it a specific image tag, then it will already have that and not need to go and pull that down again from the internet. Again, if you use latest, then it tries to get that again. And also, if it's latest, unless you keep looking it up, you don't actually necessarily know what version latest is. Maybe that changes. Like Say it's like 20 weeks down the road, and now you are running latest, but it's not the same one, and things don't necessarily work the way you thought it did. So if I create that, if I do get all, we can see right now that I have my deployment. It created that replica set, and when just creating it this way, since I didn't specify how many replicas, for instance, it just creates one by default. If I were to go and delete this pod, we can see that this one came up in 7 seconds, and it has a different name. So basically, hey, the other one's gone, something happened to it, and now it has another one back. Sometimes you might see things crash loop backup. There's a bunch of different things that you could see. If you want to be able to, so if you haven't played much of the Kubernetes, you might not know that there is a ton of YAML involved. If you hate YAML, I'm really sorry, but it's kind of part of the whole thing. So you can use kubectl, for instance, just like the way I have been, and being like, hey, create whatever resource it is. You could also use YAML if you want to actually look to see what it actually created. So if you do a kget deployment, and so you can give it a -o, and you can do YAML, you can do JSON. There is a JSON path thing that you can do to be able to get specific values. Like if I wanted to get spec.replicas or whatever it is, I could do that as well. If you pipe it into YQ, which is a separate tool, you can actually, if you like colors and be able to see things differently, you could do it that way. So basically, if you were creating your own YAML, which I'll show an example of one in a second, it's not as big as this, because a bunch of these things are there, Kubernetes is adding these for you as whatever, it shows the default values of whatever some of the things are that you don't necessarily need to specify. And you can see things like, okay, what is the name, which is what I called it as Nginx. We can see what namespace that I have it in. There's how many replicas I have, which currently is just one. There's things that you can deal with, like rolling updates. And then we can see here basically what the containers are. And as I mentioned, you can have multiple containers within a pod. For this one, I specifically just have this one, and you can see all the specific details for that. And then you can see things actually with the status, and it checks to see does it have the minimum number of replicas available, for instance. And if we look at the pods again, you can do things you can do logs on them. And then you can see things specifically for that container, and you can see what it's kind of doing. And depending on your own app, if you're creating your own application, you can see specific logs for your own application doing things like that as well. And then if you're oh, hey, well, I only decided I wanted to have one in the first place. Now I want to have more of them. You can you can scale. Oh my goodness. And then, so if I said that I wanted to do 3, if I did this again, we can see that it's slowly creating them. And if I do a watch, actually now they're all already up running, but you can see that it's taking a little time, and then it's going and running all of those different ones. So right now I have it just it's just running on my laptop. None of you can see that there is actually Nginx running. I mean, besides, you can't see the web page. Nginx running, that's great, cool. And actually, before I jump in that real quick, I'll show you an example of just what one of the YAML files looks like. So if I do a cat, this is a different one. But so for instance, this is you can see it's a lot shorter than what I showed for actually doing the describe. Or I mean, when I did the get. And so you need to give it specific labels for a little bit. You need to give it a container, you give it the image. This one you can decide what you want to do. You can decide, hey, if this image doesn't exist, just keep pulling it, or just use whatever is there, and then container ports, etc. So if I wanted to run this one as well, I can do this thing with kapply, and I give it the YAML file. So for things that are super specific and detailed, instead of having to be kubectl run this and then modify this and change a bunch of different things, because you can't always do everything that you want with kubectl. For instance, there's like certain things that you end up dealing with RBAC that you can't go and do that with. So, all right, if we do get deployments now, we can see that, or get all. Let's see, where did that go? Oh, I put that in a different namespace. Well, that's in the default namespace. So if I did get PO and default, we can see that it's running in there. So, okay. So one of the things that you can do if you're just like playing around with things is you can do a port forward. And then you can give it, oh my goodness. All right, so you can do a port forward if I just like open another, oh my goodness, that's small. If I just did a curl, I mean, I could go over to a web browser as well. Let's see if, but I don't actually, since I'm mirroring, it doesn't really matter. All right, well, that's being slow. But yeah, basically, you can just go and port forward if you, which should be loading on my browser, but my browser is being a jerk, I guess. So you can be able to just see stuff like that. But again, right now, I'm in a situation where none of you can actually do anything or see anything with that. Like, there's literally nothing that you can do. Like, I can see this. I mean, you can see it only because it's on my screen, but that's not super helpful. So that's where services come in. There's a couple ways to actually handle dealing. So if you're using YAML, you go, like, we can look at that real quick. Oh, I'm in the wrong one. Wait. Okay, so kill that. Okay, so this is an example of just a service. You can choose what type it is. By default, if you just create a service, it will be of cluster IP, which again, you can only see from within the cluster. And then, or you can do something like load balancer or node port, as I mentioned, and you can give it whatever the ports that you want. So if basically what I could do is if you're using kubectl, you can either do a create service or you can expose. So if I do expose, and I say, here's my deployment, what port, and I want to do type load balancer. And again, like since I'm running this on like a GKE cluster, then I'm paying money to Google for creating my load balancer. So if I do a get SVC or service, we can see that it ends up pending. We can see whatever my cluster IP is. We can see the port that we end up having there. And like it takes time for provisioning that. So while we're looking at that, there's some other things that we can look at. So we can do like a describe on this deployment. And you can see a bunch of information on there. So you can like see like what are the labels, what are the annotations, selectors. You can see, oh, hey, how many replicas do I want to have? How many do I actually have? You can see stuff with the pod template. And this is actually like a really good place for if something is wrong with whatever you're running, of trying to figure out, hey, why is this broken? Why is this not working? Because you can actually see the events of what's happening. So we can see, for instance, like when I did that scaling up from 1 to 3, we can see just like, we can specifically see what happened there. Or say if you get like some sort of crash loop backoff or something failed to pull like container image, you can see things like that there as well. Especially if it goes and it keeps killing your pods, because trying to get a pod log when your pod no longer exists is not exactly the easiest thing in the world to do. All right, so if we get get service again, so we have this external IP. So if I did a curl on that, we can see that now I am hitting my load balancer endpoint, and I'm actually able to go and see everything that's with that. And so if any of you all were bored and wanted to like type in that URL or the IP address, then you would be able to actually see this too. Again, I mean, it's just Nginx, but obviously if it was something a lot more interesting, then you could share your application and it would be up and running there. And one of the good things about services is that, so say you have like 3 replicas of your pod. There is basically like load balancing in a way that's done between the different replicas of your pods. It's not just like, oh, I'm just going to pay attention to this one pod, and then if that pod dies, oh no, the whole service is gone. That doesn't happen, so you don't have to worry about that part. So basically, traffic is routed between the different pods that you have there. If you want to deal with something, if you're down the road and you're like, hey, I want something more specific of I want to deal with 33% on this one pod and I want 20% on this other pod, and just trying to do something really specific, you can't do that specifically with Kubernetes by itself. You'd have to go into the realms of things like service mesh, et cetera, which depending on where you are in this journey might be a little more complicated. Actually, it's all these layers that you add up just get more and more complicated and complex, but some things to look into in the whole realm of that is service mesh and eBPF, which are things that people keep talking about nowadays. So yeah, let's see. If we do, get all again. Okay, so just to kind of look at this again, now you can see, hey, here's my pods, here's my service, it has my type, it has my cluster IP, my external IP, I have my deployment, I have that replica set that comes along with it. If you're trying to say later on, be hey, I want to use the Go client or the Java client and actually create resources using code instead of having to do things like this, you have to actually know where it belongs. So if we do KAPI resources, you can see basically where things are located. So you can see for instance, where if it's just v1, so if it's just v1, things are in core is the thing that for instance, if you're trying to create a deployment, you have to know that it's an apps v1. There are different places where these things are. And so just being able to look at things like this, it's super helpful. If you, for instance, are trying to figure out, hey, what are the things that are even there? You can do that. And then I think it's -h. Yeah, I mean, it kind of varies depending on what CLI you're using. Sometimes it's -s help, sometimes it's -h, whatever. But you can see all the different things that you can do, and it actually is really cool where it breaks it down for these are more beginner type of things. These are more of the intermediate types of things. So that. And you can go and edit stuff. So if I wanted to do k-edit deployment nginx, and you can choose using an environment variable what editor ends up opening it. For mine, I just have it as default for VI. And you can actually go there's certain rows that you can't actually manually change from this, I believe. But basically, there are certain things, if you wanted to modify something in the YAML, you could do it this way. Or if you're creating something via YAML, then you can go and modify the YAML and just do another k-apply, and it will go and update that, which is super useful instead of having to go through and do an edit every single time. And another thing that you could do is if you wanted to do, say, create deployment, if I did it this way, you can also do a dry run. Let's see. And then basically you could, instead of actually going and creating whatever resource it is that you want, if you know, hey, I don't want to have to type all this YAML, but I know there's some things I want to change, you can do it with the -s dry run equals client and then spit out the YAML, and then you could just be here, let me pipe this into, I don't know, my very useful file name. But if I did a cat on that, then I have the file, and I can just change that and apply it and whatnot, which is also useful when you're trying to get rid of resources. Instead of being kubectl, delete this service, delete this thing, delete that, you could just do k delete -f and then give it the file or whatever multiple files that you have, and it'll delete all the resources that you created with that, which can be super helpful. And yeah, just kind of depends on how you want to go about dealing with things. And then also another thing is if, for me, for instance, if I was hey, if I look at my namespaces again, if I went to a different one, I'm just going to jump to default. You could just be all right, I have all that stuff running in my Devoxx namespace, that's annoying. I don't want it anymore, and you could just delete the namespace and it deletes all the stuff that is running there. You just have to make sure that what you're running is actually bound to a namespace. Like, so when you're dealing with like RBAC later on, there's like this concept of you have a role, and then like the role, for instance, could be like, hey, in this namespace, you can view things that are in this namespace. There's also the concept of having a cluster role, which is not bound to a namespace. So if you created a cluster role or you create a cluster role binding and you delete the namespace, those things are still going to exist because, well, they're not bound to a namespace that you just deleted. So there's like a lot more stuff that obviously I can't get into all the things. But yeah, if we just like did a kget-ns now, we can see that, I mean, there's a bunch of stuff here, but we can see that there's none for Devoxx anymore. So let's go back to PowerPoint. Okay. Yeah, so some other things to look into. There's config maps for like, you can basically add like external things that you want to specifically change or whatnot, or like specify. Like for one random example is like, hey, I have that Nginx webpage. It just has whatever is Nginx, but I don't want to create my entirely own like web server, et cetera, but I want to use Nginx, but I want it to say something different. You could go and create a config map and have a volume and have it replace the index.html file that you have in there with whatever thing that you end up wanting to do. So that's where volumes ends up coming in a way. There's things that you can do with auto scaling. There's ingress. There's basically a bunch of different stuff. So again, it like kind of becomes a lot if you're trying to be like kubectl do blah. And maybe like one way of handling that, if it's something super small, is you could do a little bit of scripting that you needed for using kubectl. And then you can also like have your YAML that you can commit to some sort of repo. There's the Carvel tool suite, which has a bunch of different things in there. So like what I've been doing with like kubectl and everything with like, you could do -f, here's a bunch of files. But like, say you did kubectl -f on a bunch of different files, you have a bunch of resources running, you forget about it for like a month, you don't know where the file is, trying to be like, hey, I just want to get rid of all this stuff that's related to this one application. It can be kind of complicated. So there's things in the tool suite like cap, where you can specify everything that you're giving with that file is an application called like, I don't know, let's just say yellow. I don't know, whatever. But so later you can be like, oh, hey, list all the stuff that is in yellow and go, or delete everything in that, and you don't have to worry about where is this file located. It doesn't matter. There's stuff with YTT, which helps you deal with YAML templating, because once you start digging further into the weeds with Kubernetes, there is so much YAML, and having to be like, here's my deployment for this, and I just want to change this one variable or this one image name, and here's like 50 million files that have the exact same thing with just like a slight change. Instead, you could deal with tools with like, so there's YTT, there's customized, you can do with Helm, with the different YAML templating to just like be like, here, replace these specific values, but use the same YAML file for all of these different things. So basically, there's just so much stuff there that goes into the whole side of like GitOps and whatnot as well. And then here's a bunch of other links and resources. So there's just like the Kubernetes docs. So as I don't even remember if I mentioned, I work at VMware. So we have this tanzu.vmware.com. If you do /developer, or if you just go to tanzu.tv, which jumps to part of it, we have a bunch of different like blogs and guides, tutorials, and like videos and stuff that you can go through and workshops to learn more. My friend Jerome Pedizzoni has a container.training with a bunch of workshops that you can look at. There's the Kubernetes community, so there's like Slack, there's Google Groups, there's a bunch of meetups, especially as things have been going on. A lot more places are having meetups again, which is pretty cool. And then there's some more, and the stuff I mentioned is all free stuff, because free. I mean, it's good. And then there's some more free training. We have this thing called Kube Academy, where you can do like certain like courses of learning various things, whether it's intro Kubernetes, whether it's Spring, because like half of my team deals with Spring, and that, if you don't know what that, it's a Java framework. Then there's on the Kubernetes docs, there's tutorials, and then there's also this labsplaywithkates.com as well. So yeah. Thank you for coming and sitting through this, and hopefully learn something. And assume there's a way to rate stuff, and I'm curious for feedback and stuff, so please click something in there. That would be great. So yeah, thank you.